This is the next video on analytical geometry. And let's just read the thing at the top here. They give a point A, B, and C in the coordinates. They say there's a point D down here that's XY. They say that this ABCD is some kind of quadrilateral. They tell us that AD and CB are parallel to each other. And they see that BA is produced to make E here, which is an x-intercept. See, it's on the x-axis. And they say AC is got an x-intercept here at n, t, and 0. So that's all the information. It's a point on AD. And there's the information. Let's get to the questions. Here we go. Calculate the gradient of BC. Well, that's pretty straightforward. You just go to B and C and you go 5 minus 3 over 6 minus 0. The change in y over the change in x. Subtract the 2y and subtract the 2x, and there you go. Minus 3 minus 5 over 0 minus 6. It's minus 8 over minus 6. Two negatives make positive 4 over 3. You could go the other way. You still get the exact same answer. Now the next question, let's take a look. Determine the equation of AD. Well, let's look at AD. AD, the equation of this line AD. We go, gee, we don't know x and y, but hey, we know that BC and AD are parallel. So the gradient of BC will be the same as the gradient of AD. And we just got the gradient of BC. We just did it. It was 4 over 3. Well, there you go. You could put that gradient of 4 over 3, you can put it into the formula y minus y1 equals m times x minus x1, and take the point of x is minus 2 and y is 2 and put it in that formula. You'll get the right answer. But you can put it into y equals mx plus c. It works just as good. We know m is 4 over 3, so we put 4 over 3 in there. Say we don't know the y-intercept. Well, all you do is x is minus 2, that's the point D, I think, and y is 2. You multiply it out, you get minus 8 over 3, and you add it to 2, and you get that c must be 14 over 3. And there you go. There we've got the equation of the line AD, or the line that passes through AD anyways. Now, determine the value of t. We'd like to know t. But we know we've got the equation of the line. And hey, it's an x-intercept. Well, that is easy. An x-intercept, we just let y equal 0. And that's what they do. They take y. There's the equation of the line. You let y equal 0. And that's it. Well, let's subtract 14 over 3 from both sides. We get t like this. Hey, if you multiply both sides by 3, the 3's are going to disappear. They're going to become 1. They don't really disappear. But then you divide by 4. Negative 14 divided by 4. Oh, that's minus 7 over 2. That's what t is. And the last question. The last question says, calculate the length of AN. Let's take a look at A to N. Well, now we know what t was. It was that fraction minus 7 over 2. All we do is put that in the distance formula. Let's put it in the distance formula, and we go minus 2 minus 7 over 2, because that's the point t, and the change in y is 2 minus 0. And you actually go minus 2 plus 7 over 2. You square it, added to 2 squared, which is 4. Your calculator will tell you it's 25 over 4. Take the square root of 25 over 4. Root 25 is 5. Root 4 is 2. The answer is 5 over 2 for the distance AN. And there you go. That's the first 4 questions of the analytical geometry part. We'll do the next in the other video.